6.2a, for this lesson, we're going to classify polynomials and perform synthetic substitution. All right, so a polynomial, in order for something to be a polynomial, we need to have whole number exponents. Okay, whole numbers are those counting numbers that we count by. So 0, which includes 0, also 0, 1, 2, 3, 4, 5. So the exponents have to be those whole numbers, and then the coefficients have to be real numbers. Okay, so those are the two restrictions to making sure something's a polynomial. Now, the degree of a polynomial is what's going to be the largest exponent. Okay, so you go through a whole polynomial, whatever exponent is the largest, that is the degree of the polynomial. And then the leading coefficient is the number in front of the first term, so the coefficient of the first term when in standard form. So we'll go over how to get something in standard form in here in a second. But the way we classify, okay, there's two ways we classify polynomials: by its degree and the number of terms that it has. Okay, so when a polynomial has a degree 0, that is what we consider a constant. Okay, so degree 0 is constant. Degree 1, we've talked about these a lot. These are linear. Okay, degree 2, that is what we have a quadratic. Degree 3 is cubic. Degree 4 is what we consider quartic. And finally, when we get to degree 5 or degree 6 or degree 7, that's where we just classify them as degree whatever it is. So degree 5, degree 6, degree 7, so on and so forth. All right, so let's come up with some examples. It's a function, so f of x, and if it's a constant, again, we have a exponent, largest exponent is 0, and it's just going to be a number. Okay, 4, 5, anything. There's no variable, there's no exponent. And when you see that, it's a degree 0. Linear, you're going to see x plus some value. You could see just x. Okay, but the biggest thing is that the largest exponent there is 1. Quadratic, largest exponent will be 2. So you could say 2x squared. Okay, and you could have plus x, plus 5x, plus something. Okay, but the biggest thing is that the largest exponent is that 2. Cubic, again, same idea, except now the largest exponent is 3. Now, I'm going to write something that's not in standard form, so we'll say 2x squared plus 3x cubed. Okay, the largest exponent, again, is still that 3, so that is degree 3. Quartic, same idea, except the largest exponent will be 4. Okay, degree 5, largest exponent is 5, 6, x to the 6, and again, you can have x to the 5th plus x to the 4th. The biggest thing is that the largest exponent is 6. Now, the other way we classify polynomials is by the number of terms. Okay, when there's one term, so like if we look at, let's say, our constant example, there's only one term here, that 4. In those cases, we consider those monomials. Okay, mono is 1. Okay, when we have two terms, okay, an example where we have two terms would be our cubic function, 2x cubed plus 3x cubed. That is two terms, and when we classify something with two terms, we call that binomials. Okay, bi meaning 2. 3 terms, we have an example with our degree 6 function there. Okay, x to the 6th plus x to the 5th plus x to the 4th, that's 1, 2, 3 terms. When we have those and we're classifying them by the number of terms, that is called a trinomial. Okay, tri meaning 3. And then 4 terms. Okay, anytime we get 4 or more terms, this is a case where we just consider it a polynomial. Okay, so there's the 1, 2, and 3 terms. Those are the most common ones we typically see. So we have specific names for them. There are specific names for further on, but for our class, we're just going to consider 4 or more terms. We're just going to consider those polynomials. All right, so let's go ahead. Let's classify, given a function, let's classify them. Decide whether the function is a polynomial. If it is, write it in standard form, state the degree, classify by degree, and number of terms, and identify the leading coefficient. Okay, so again, when we're trying to determine if something is a polynomial, we need to have whole number exponents and real coefficients. So I'm going to go to my exponents, 2, 3, and we imply that that is 1. Those are whole numbers, so that part is good. And then when we go to the coefficients, 3, 2, 4, those are all real numbers. Therefore, this is a polynomial. Okay. Now, in order to be in standard form, okay, we still have a function, so f of x. Our exponents should go in descending order. Okay, so x cubed will go first, because that is the largest exponent, so negative 2x cubed. X squared would be next, so plus 3x squared. Then finally, plus that 4x. Our exponents are going in descending order. So that is standard form. Now, degree, again, if it's in standard form, your degree should be in that first term. So when we're in standard form, all we have to worry about is looking at that first term. Degree 3, which we classify as a cubic function. Okay, and then classifying, degree is 3. And when we classify by the degree, it is a cubic. Okay, classifying by number of terms, then we got 1, 2, 3 terms. 3 is tri, so trinomial. And then finally, the leading coefficient again is the coefficient with that first term in standard form. So in this case is negative 2. All right. So the next one, looking at it, we got our exponents 2 and negative 2. And again, our exponents need to be whole numbers. Negative 2 is not a whole number. Again, whole numbers are counting numbers including 0. So 0, 1, 2, 3, 4, so on and so forth. Negative 2 is not a whole number. Therefore, this is not a polynomial. And since it's not a polynomial, we cannot classify it by anything else. All right. So looking at a couple more examples. Determine if it is a polynomial. We got cubed, x to the 4th. And then when we have that constant term, that is when the exponent is 0. So this case, well, that's our exponent, so we're good there. Okay, looking at our coefficients, we got negative 0.8, 1, and negative 5. Those are all real numbers. Therefore, it is a polynomial. So standard form, f of x, looking at our original function, we got x cubed, x to the 4th, x to the 0. Again, that constant term here, that's like saying x to the 0. X to the 4th is the largest exponent, so that's the term that will go first. X cubed, so negative 0.8 x cubed, and finally that minus 5. And again, when we have it in standard form, everything else we need will be with that first term. Degree 4, that is the largest exponent. Classified by degree, degree 4 is quartic. Number of terms, we got 1, 2, 3 terms, so a trinomial. And then finally, the leading coefficient, again, will be the first number, the first coefficient you see in standard form. Okay, there's nothing there, so we imply that it is 1. All right, so next one. Our exponents, degree 1, 4, 2, and that would be 0. So our exponent part is good. Looking at if our coefficients are real, we got negative 1, square root of 5. Square root of 5, you plug that into the calculator, you will get a real value, 2 and 7. Therefore, this is a polynomial. Now, let's say if this was square root of negative 5, that would be I root 5. That's a case where it would not be a real value. Okay, so keep those in mind moving forward. All right, standard form, f of x, looking for that largest exponent, square root of 5, x to the 4th, that was our largest exponent. We have a squared term that would come next, so plus 2x squared, then minus that x, minus 7. So when you put something in standard form, make sure to look at your exponents, make sure that they are going in descending order, which they are. All right, so degree. Again, looking at that first term when in standard form, degree 4, which is a quartic function when we classify by degree. number of terms, we got 1, 2, 3, 4 terms. Okay, so in this case, we are just going to consider it a polynomial. Poly meaning many. Okay, and then finally, our leading coefficient is that square root of 5. All right, so that is how we classify polynomials, put in a standard form. Determine degree, classify by that degree, classify by the number of terms, and then our leading coefficient. All right, so now synthetic substitution. This is a new topic for you guys. Typically, if I was to say, okay, if x equals 4, what would the function be if we plugged 4 in? You plug 4 into x. Now it's a little bit different method. Okay, so place the x value on the outside. That is our first step for synthetic substitution. Our x value is 4 in this case. So 4 will be on the outside, and then we're going to make a little box. Okay, from there, you're going to list all coefficients in descending order. So we got x cubed, so our x cubed term will be there, and then we're going in descending order. Okay, so we got 5 for our coefficient for x cubed, 1 for x squared, -4 for x, and then 1 for our constant value. Okay, so that's our setup. Now to solve, what you're going to do is going to bring down that leading coefficient. So you're always going to bring down that 5, or whatever number that is for that leading coefficient. From there, you're going to multiply those two numbers, and that will go into the next spot. And then you add 1 plus 20. Okay, and then again, multiply. 4 times 21, we're going to get 84. Again, add, which will give us 80. And then multiply again, 320. Add, 321. So if we were to plug this in, 4 into that function, we would get a total of 321. So f of 4 is equal to 321. So that is synthetic substitution. Synthetic substitution is just evaluating a function. All right, so number 2. Okay, here we're evaluating when x is equal to 3. So 3 will go on the outside of the box. And going in descending order, we are in standard form. So -2, 5, -3, and 4. Now, we have a cubic function here, so you should make sure there's always one more than the degree. So it's degree 3, so we should have 4 coefficients in there. Again, bring it down. The first coefficient, multiply, add. Multiply, add. Multiply, add. So -14. So f of 3 is equal to -14. All right. Now, the next one's a little bit trickier due to the fact that we got some terms in between our 6-degree term and our 1-degree term. Okay, so again, whatever x value we're evaluating, that will go on the outside of the box. But now, we start with x to the 6th. That coefficient is 1, but that x to the 5th, x to the 4th, x cubed, so on and so forth. X squared, x, and our constant. Okay, our x to the 5th term, our coefficient with that is 0. Okay, x to the 4th, coefficient 0, 0, 0. Then we get to our linear term, 3 and 4. It is important that we have these zeros in here in place of the 5th-degree term, 4th-degree term, cubic term, quadratic term. Okay, that is a common mistake a lot of people make. A lot of people would like to set this up as 2, 1, 3, 4. You are missing all those zeros in there, so make sure to have those in there to represent those place values. So bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, and we get 74. Okay, so in this case, f of 2 is equal to 74. All right, so again, that's a new concept. So make sure to definitely give those a try. If you had a hard time following me with that synthetic substitution, there's another YouTube video that will walk through synthetic substitution as well. It looks a little bit different. If you go that route, that is fine. But for your assignment 6.2a, use synthetic substitution to evaluate. Use direct substitution. So direct substitution is when you're just plugging in that value into x. Okay, and then finally determining if something's a polynomial, and then stating the degree, type, and then the leading coefficient. All right, so if you have questions, make sure you ask those. Otherwise, have a good day.